The aim is to create a musical instrument in the form of a computer program that takes in various input data and processes them to shape an outgoing sound signal. The user will interact with the sound-producing software with the use of a smartphone as a motion controller. Additionally, data will be gathered about the user's environment and processed by the instrument to produce an infinitely varying musical soundscape. To implement my ideas, I decided to use the open source programming language Pure Data for constructing the sound engine. This language is designed to process sound signal in a modular environment, which is easy to navigate through because of its visual interface. Input data is delivered to the sound engine with the use of the OSC protocol. Motion data is collected with an iPhone XS equipped with a Gyro OSC app, collecting data from the phone's gyroscope and passing them on. Environment data, namely weather and time, are collected in the programming language Python with the help of the Open Weather API. These components work synergistically to produce a motion-controlled ambient soundscape reflecting the instrument's environment. Let us now look at the construction of these components in more detail. The motion control is facilitated through the Gyro OSC app. In the main screen of the app, the user inputs a desired IP address to send the data to, along with a port number. We then select gyroscope data as our output and allow the app to run in the background. The time data collection occurs in Python. First, a UDP connection is established. The program then collects and formats the time data. Subsequently, data is processed and supplied with tags to be able to map it correctly to sound processing. Finally, the data is sent off to the sound engine and the data collection process repeats in 10 seconds. Similarly, the weather data collection also occurs in Python. First, the program connects to the Open Weather API, from which the data is fetched. After this, a UDP connection is established. The program then collects weather data from the API. Subsequently, data is formatted, processed, and supplied with tags to be able to map it correctly to sound processing. Finally, the data is sent off to the sound engine, and data collection process repeats in 10 seconds. Let us now focus on the main component of the instrument, the sound engine. To be able to play music in a rhythmical arrangement, the instrument is equipped with a sequencer, determining the overall tempo. The sequencer has a processing unit, outputting lengths of different segments of the soundscape, and a control unit, where the user selects a desired speed. The most important part of the engine are the melody processors. There is an upper melody consisting of 3 melody units, middle melody consisting of 2 units, and lower melody which only has 1 unit. Each unit includes 3 phaser objects, sawtooth oscillators outputting frequencies provided. Frequency to be played is decided by the melody selector objects, and original frequency is detuned in both directions to provide more depth to the output sound. The amount of detune is determined in detune selector objects based on weather conditions. A unit is also equipped with an envelope to fade out and output sound after some time. The melody is decided based on temporal conditions. There are 14 possible keys to choose from, and the key changes every hour. The key for all melodies is always kept the same to prevent dissonance. There are 4 chords in each key, and they change in different intervals in each melodic part. Lower melody has 3-note chords, while middle and upper melodies have 4-note chords. The specific tone to be played by each melodic unit is randomized to introduce endless variation. All melodic units are routed together in a mixer, which combines them into a singular soundscape. Reverb is applied to middle and upper melodies to glue the mix together. Inputs are collected in Pure Data using specific port numbers. Based on how the data is tagged, it is sent off into the correct processing automatically. The sound engine is encapsulated in a simple user interface. This includes a switch to turn the sound engine on and off, and a switch for each data collection component. Features, which are mapped to motion control, are visualized using a number box, aiding the user in interacting with the instrument. The features mapped are tempo and 2 high-pass filters, one for the middle melody and one for the upper one. All components mentioned before are encapsulated in objects and hidden from the user initially to prevent distraction. The parts mentioned before are combined to produce a soundscape.